Hello everyone. So in this lecture we will be doing exemplar from the chapter integration. Um, so in this lecture we will be attempting short questions and the notes will be available as the Google Drive link below the video. Also there are timestamps so that you can go to the particular question you are trying to solve. So let's begin. So our first question here is integrate uh, 2x minus 1 divided by 2x plus 3 dx. So what I can do is create 2x plus 3 in the numerator also. So 2x plus 3. So minus 1 है वहाँ पे. So what will हमें क्या लिखना पड़ेगा वहाँ पे? Probably we will have to write minus 4, right? Because it is still 2x minus 1 divided by 2x plus 3 dx. So this becomes it becomes 1 minus 4 by 2x plus 3. So हमारे पास दो टर्म्स आ गए यहाँ पे. So we can write two integrals. So first integral is of dx. Second integral is negative 4 outside 1 by 2x plus 3 dx. So this is x minus 4 times. So इसका integration क्या होगा? Log of mod 2x plus 3 but also divided by 2, right? So plus some arbitrary constant. So what do we get? So we get x minus twice of log mod 2x plus 3 plus c. So we can take this 2 inside the log to write x minus log of. So अंदर a perfect square है, so it is already positive. You need आपको mod लिखने की कोई जरूरत नहीं है. Square plus c. So which matches with this RHS. Okay. So very simple question. So now let's move to our next problem. Okay, so in this next problem we have a linear by quadratic. So generally in linear by quadratic अगर so there are few number of methods here, but for example अगर नीचे quadratic factorizable ना हो, then you can write the numerator में जो linear है as a times g dx of denominator plus b, and you can find a and b. Or you can factorize the denominator and do partial fractions, but right now it looks like denominator का differentiation is numerator. We can take x square plus 3x is equal to some t. इसका differentiation क्या आ रहा है? 2x plus 3, right? Which is same as the numerator. It is dt by dx, so into dx is dt. So our integral now just changes and it becomes, numerator becomes dt and denominator becomes t, and result is uh, log mod t plus c. So which is log mod t कितना है? x square plus 3x plus c. Okay, so now we can move to our next problem. Okay, so in this next problem, as we can see, numerator में power ज़्यादा है denominator से, so we need to do long division. So we'll divide x square plus 2 with x plus 1. Let's see what we get. So we get x into x square plus x. So minus minus, and these two cancel and I get minus x plus 2. So then we can multiply with minus 1. So we get minus x minus 1. So plus plus, and these two cancel and we get plus 3. So right, plus 3. Okay. So we can write numerator, which is the dividend, is equal to divisor into quotient plus remainder. So x plus 1 into quotient x minus 1 plus remainder plus 3 divided by x plus 1 dx. So जब हम इसको डिवाइड करेंगे इस टर्म को ऊपर ले दोनों टर्म से, we will get x minus 1 into, so plus में 3 divided by x plus 1 dx. So we can write two integrals. So एक है x minus 1 का इंटीग्रल and second है 3 outside, 1 by x plus 1 into dx. So यहाँ पे x का इंटीग्रेशन कितना होगा, x square by 2 minus 1 का इंटीग्रेशन will be minus x plus 3 times log mod x plus 1 plus c. Okay, so which matches with the result on the back side of the exemplar. So let's move to our next problem. Okay, so in this problem, let's see what is given to us. So we are given e की power 6 log x minus e 5 log x divided by e 4 log x minus e 3 log x. So one thing we can do is we can use this property a times log x क्या होता है, so n times log x क्या होता है, so this is log of x and x की power n, right? So power can go inside, so we'll use this property of log and to write this new integral which is e की power log of x की power 6 माइनस e की पावर, तो यहाँ पे 5 अंदर जाएगा log के एंड यहाँ पे log के अंदर क्या आएगा x की पावर 5 डिवाइडेड बाय e log x की पावर 4 and minus e log x cube. Okay, so now we will use a formula which is, so you can write it in both ways कि log के अंदर e अगर e की पावर अगर सम n आता है, so this is same as n can go outside, right? Log e and which is n, right? Okay, so or e की पावर log, if you are calculating n या फिर x, so this is also n. So so first formula कि log en क्या होता है, n होता है, and for example e की power log, so these are inverse function, right? E and log are inverse functions. So this is the second formula. So let's prove the second one. So for example, we want to prove, so we want to prove कि e of log n क्या होता है, n होता है. So for example, let's assume answer is some y, right? ठीक है, so y is equal to e log n. So this complicated term is e log n, and what we want to do is simplify y. So what we'll do is take log. So this is the LHS, right? ठीक है, LHS को मैं assume कर रहा हूँ y. So LHS में log लेते हैं. So log y is log e and उसकी power क्या है, log n. So log n can go outside. Log y is equal to log n. So this is the power, it will go outside into log e. But what is log e? Log e is 1, right? Now क्योंकि base e है, natural log a, and we get log y is equal to log n, and from this we can say y is equal to n. So from this first statement and second statement, we have this is the RHS, right? Okay, so we have our proof. So from this, what we can conclude about this integral is, so I can say this is x की power 6, right? Minus x की power 5 divided by x की power 4 minus x cube dx. So let's solve it further. So क्या कर सकते हैं, न्यूमरेटर में से हम क्या कॉमन ले सकते हैं, x की पावर 5 कॉमन ले सकते हैं, and inside I am left with x minus 1, and from denominator I can take x cube common, and inside I am left with x minus 1. So x minus 1 cancel कर देते हैं, and x की power 5 by x cube is x square. So integration of x square is x cube by 3 plus c. Okay, so which is the result for this question. So now let's move to our next problem. Okay, so here is our next problem. I don't think it is very difficult. लग रहा है थोड़ा, but as you can see denominator में जो x plus sin x है, we can take this as the substitution, and इसका differentiation कितना आएगा, 1 plus cos x, right? Okay. So this is equal to dt by dx, so into dx is dt. So with these substitutions, our question now becomes dt and 1 by t. So answer is log mod t plus c. But what is t? T is x plus sin x. So this is log mod x plus sin x. plus c. Okay, so which is the result on the backside of the exemplar also. So let's move to our next problem. Okay, so here is our next problem. So probably we can solve this question in more than one method. So method one. So we already know what is 1 plus cos x in using the half angle formula. So this is twice of cos square x by 2. So 1 by 2 outside, and cos square x by 2 will become secant square x by 2. So whose integral is? So you can take substitution x by 2 is equal to t and all that, but you can do it directly also, tan x by 2, but divided by half. So this is tan x by 2 plus c. Okay, so we can do a method 2 also. So method 2, what you can do is try to rationalize this. So like class 10th, so 1 minus cos x and 1 minus cos x. So numerator में बनेगा 1 minus cos x, denominator में बनेगा 1 minus cos square x, which will become a single term, which is sin square x. So you can divide by sin square x with both of the terms. So 1 by sin square x and minus cos x by sin square x, which just मैं split करके लिख रहा हूँ, cos x by sin x into 1 by sin x. Okay, so first integral is cos x square x, and second integral is cot x into cosec x. Which are both standard formulas from NCERT, right? So let's try to complete this. So we will get integration of cosec square x, negative outside, integration of cot x into cosec x dx. So integration of cosec square is minus cot x, and integration of cot x into cosec x is minus cosec x. So we get cosec x minus cot x plus c as the result, but you can argue कि exemplar के पीछे ये answer given है, for example, and are these answers same? Yes, you can prove it using trigonometry. So let's prove that also. So for example, what is cosec x minus cot x? So cosec x minus cot x can be simplified. So you can write it as 1 by sin x minus cos x by sin x. So this is 1 minus cos x divided by sin x. Now you can use half angle formula. So numerator ko you can write as let's say twice of sine square x by 2, and denominator can be written as twice of sine x by 2 into cos x by 2. So 2 cancels, one of the sine x by 2 cancels, and we get sine x by 2 by cos x by 2, which was the other result, right? Tan x, tan x by 2. So of course we can prove this, right? So this is tan x by 2. Okay. So now let's move to our next problem. Okay. So uh, in this integral, we can separate one of the secant square, separate अलग से लिख लेते हैं, tan square x into secant square x into secant square x. So what we will do, write the other terms in terms of tan. So जो second वाला first वाला जो secant square है, उसको we will write as 1 plus tan square x. So what we can do now is we can take tan x is equal to z as a substitution. So secant square x into dx will be dz. So this term will get absorbed, and we can write z square into 1 plus z square dz. So which is integration of z square dz plus integration of z की power 4 dz आंसर क्या आएगा? z cube by 3 plus z5 by 5 plus c. So let me bring it down. Okay. And what is z? So what is z here? Z is tan x. So our result is basically tan cube x divided by 3 plus tan 5x divided by 5 plus c. Okay, so now let's move to our next problem. Okay, so generally in such problems, अगर ऊपर sin x plus cos x होता है, we try to create sin x minus cos x जैसे term, because for example sin x plus cos x का differentiation क्या होता है? So that will be cos x minus sin x, right? And cos x minus sin x का differentiation will be minus sin x and minus cos x, negative common. So basically it is sin x plus cos x. So generally we try to create the negative वाला term, अगर ऊपर positive है तो नीचे negative वाला, but right now numerator and denominator में same ही term given है if you notice carefully. So we can basically cancel them. So let's see. So this is a simple question basically. Sin x plus cos x and denominator में क्या है? So this is 1 sin 2x को लिख सकते हैं 2 sin x cos x, right? ठीक है. And 1 को हम लिख सकते हैं sin square x plus cos square x. So and you can see denominator में we have a perfect square. So numerator and denominator cancels and we get integral of dx, right? Okay, these two will cancel, square root and square will cancel, so sin x plus cos x will cancel, and our result is x plus c. Okay, so just a trick question. Generally, of course, sin x plus cos x का differentiation कैसा होता है? Cos x minus sin x, and इसका differentiation कैसा होता है? Negative of that, right? So and that keeps on going. So generally अगर ऐसा क्वेश्चन होता तो मैं नीचे cos x minus sin x का whole square बनाने का ट्राई करता, but this was a trick question. So let's move to next problem. Okay, so just like the previous question, probably we can remove the square root in this question also. So let's do that. So this can be written as 1 plus twice of sin x by 2 into cos x by 2. तो इस बार हम 1 को क्या लिखेंगे? Sin square x by 2 plus cos square x by 2, right? So this will become sin x by 2 plus cos x by 2 whole square. तो अगर ये डेफिनेट इंटीग्रेशन का क्वेश्चन होता तो then you have to be very very careful, because square root of x square is not x, it is mod x, right? So answer will be always positive. So you have to take care of the quadrant also in definite integration, but right now I can simply say this is sin x by 2 plus cos x by 2. Okay, so how to solve this further? So sin x by 2 का इंटीग्रल क्या होगा? So and cos x by 2 का तो sin x by 2 होगा, but divided by half, and sin x by 2 का इंटीग्रल will be minus cos x by 2 divided by half plus c. So this result can be simplified as minus 2 times cos x by 2 plus 2 times sin x by 2 plus c. Okay, so now let's move to our next problem. Okay, so hint is also given here. So to do this question, we can remove this square root from the denominator by putting root x is equal to z. But root x का differentiation 1 by 2 root x होता है, which is not available. So what I'll do is square this. So I'll get x is equal to z square as the substitution, right? So I can differentiate now. So dx should be equal to 2z dz. So this integral will now change. तो हर जगह हम x की जगह क्या लिखेंगे, z स्क्वायर, एंड नीचे वाले रूट x की जगह z आएगा +1, एंड हमारा जो dx है उसकी जगह आएगा 2z dz. ओके, सो so this integral will become 2 can be taken outside, and z cube divided by z plus 1 dz. So we can do long division now. So long division करते हैं. So ऊपर का पावर ज़्यादा है. So after long division, so z cube अंदर. So z plus 1. So z square, z cube plus z square, minus cancel. So minus z square, minus z. So minus z square and minus z, plus and these two cancel, and this is z and z, and then um, so what I can do is +1. So z plus 1. So minus and minus, these two cancel, so this is -1. Okay, so now I can write numerator as so divisor into quotient plus remainder, right? So z cube can be written as z plus 1 into z square minus z plus 1 minus 1 divided by z plus 1. So after division we have two terms. So we have twice of z square minus z plus 1 into dz, and second term is minus and 2 outside 1 by z plus 1 dz. Okay, so this is twice z cube by 3 minus z square by 2 plus z, and minus twice of log mod z plus 1 plus c. So हमें अभी z का वैल्यू वापस डालना है, which is root x. So let's put some space here. So okay, so z का वैल्यू हमें डालना है root x. So let's do that, and let's multiply the 2 inside also. So we get 2 by 3, and z cube क्या बन जाएगा? So if z is root x, so z square क्या होगा? x, and z cube कितना होगा? So this is x की पावर हाफ की पावर 3, so x की पावर 3 by 2, या फिर x root x. Okay, so you can write this as x root x. माइनस में 2 कैंसिल, z स्क्वायर की जगह आएगा x, एंड z की जगह आएगा सो ट्वाइस ऑफ z की जगह आएगा ट्वाइस ऑफ रूट x, एंड माइनस ट्वाइस ऑफ लॉग मॉड रूट z plus 1 plus c, which is the result given on the back side of the book also. Okay, so now let's move to our next problem. Okay, so in this problem probably we will have to do a substitution. For example, good substitutions are like these: a square minus x square के केस में you can put x is equal to a sin theta, and x square minus a square के केस में you can put x is equal to a secant theta, and x square plus a square या फिर a square plus x square, इस केस में you can put x is equal to a tan theta. There are other forms also, कि for example square root of a plus x या फिर square root of a minus x. So in these cases x is equal to a cos 2 theta works the best, and question में दोनों हैं ये, right? So we should put x is equal to a cos 2 theta, and that this will work. Let's see how. So let's say x is equal to a cos 2 theta. So dx will be a times cos 2 theta का integration is minus sin 2 theta into 2, so into d theta. So dx is minus 2a sin 2 theta d theta. So this integral will change, and you can see here also ki a plus x, for example, will become a plus a cos 2 theta, right? Okay. So root a can go outside, and we will be left with root of 1 plus cos 2 theta, and so root a times 1 plus cos 2 theta कितना होता है? Twice of cos square theta by 2. So and root 2a times cos 2 theta by cos theta by 2, right? Okay, so this question can be proceeded in this way, right? Okay. So which can be now then integrated. So let's do this one. So यहाँ पे in the similar fashion हमारा न्यूमरेटर क्या बन जाएगा? A plus a cos 2 theta divided by a minus a sin 2 theta. So cos 2 theta d theta. So a from the numerator and denominator will cancel, and we will get 1 plus cos 2 theta by 1 minus cos 2 theta. Okay. So proceeding further. So numerator हमारा बन जाएगा twice of cos square theta. अच्छा, तो यहाँ पे गड़बड़ कर दी ना, twice of, क्योंकि यहाँ पे ऑलरेडी 2 थीटा, तो वहाँ पे थीटा बाय 2 नहीं आएगा. It will be just twice of cos square theta, and this will be cos theta, right? Okay. But यहाँ पे हाँ, and divided by twice of sin square theta, half angle formulas, 2 cancels, and square root of cot square theta, which is cot theta, d theta. So what is the integration of cot theta? So अच्छा, हमने मिस कर दिया कुछ टर्म, ठीक है. So we missed a few terms. Let's do the correction here. Once we do the substitution, हमें dx की वैल्यू क्या डालनी थी? हमें dx की वैल्यू डालनी थी -2a sin 2 theta d theta. So -2a goes outside, right? And यहाँ पे क्या है? sin 2 theta d theta, sin 2 theta d theta. So probably मैं यहाँ पे इसको cot theta की जगह cos theta by sin theta ही रहने दूंगा. So and we will open sin 2 theta also. So this is -2a, and this is cos theta sin theta, and let's open this sin 2 theta as twice of sin theta cos theta. So these two can cancel. So 2 will also go outside, so -4a into cos square theta. So cos square theta is very simple to integrate. So you can use the double angle formulas for that. So you can write cos square theta as 1 plus cos 2 theta by 2. So this will become integration of 1 plus cos 2 theta divided by 2. So 2 will go outside, and outside we will have -2a, and then integration of 1 plus cos 2 theta. So let's put more space here. Okay. So we have -2a integration of d theta, -2a integration of cos 2 theta d theta. So this is -2a theta and -2a times cos 2 theta का integration is sin 2 theta by 2 plus c. So this is, so अब हमें थीटा की वैल्यू वापस डालनी पड़ेगी. एंड आवर सब्स्टिट्यूशन वाज, हमने x की जगह डाला था a cos थीटा राइट. तो x की जगह हमने डाला था a cos 2 थीटा. तो x was a cos 2 थीटा. तो ठीक है, हमें यहाँ पे जो जो वैल्यूज चाहिए उनको कैलकुलेट कर लेते हैं. फर्स्ट वी रिक्वायर थीटा. तो फ्रॉम दिस वी कैन से x by a is cos 2 थीटा. So which implies 2 theta कितना है? Cos inverse x by, and theta is half of cos inverse x by. तो यहाँ पे आएगा half of cos inverse x by. So this is, and what about the second term? तो हमें sin 2 theta की वैल्यू चाहिए. So we already have this value. So I'll ठीक है, इससे आप sin 2 theta की वैल्यू निकाल लो. So this will be square root of 1 minus cos square theta. Cos square 2 theta. This is sin 2 theta, right? और ये कितना होगा? स्क्वायर रूट के अंदर 1 माइनस एक्स स्क्वायर बाय ए स्क्वायर. तो दिस 1 बाय स्क्वायर रूट ऑफ ए स्क्वायर माइनस एक्स स्क्वायर. ओके, तो यहाँ पे आई विल यूज 1 बाय इंटू स्क्वायर रूट ऑफ ए स्क्वायर माइनस एक्स स्क्वायर प्लस सी. तो हमारा आंसर क्या बन गया? अवर रिजल्ट इज माइनस ए कॉस इनवर्स एक्स बाय ए प्लस, so and then minus root of a square minus x square plus c. So let's just check this answer. Yeah, so it's fine. Yeah, वहाँ पे बाहर a है और अंदर एक a 1 minus a x square by a square है, but you can just take it out like this, right? ठीक है, and cancel the a. So this is the same result. So now let's move to our next problem. Okay, so this is our next problem. So as given in the question, we will do this substitution. So x की value डाल दे z की power 4, and that is a good substitution because denominator में जो fractional power है 1/4 है. If we put x is equal to z की power 4, so all the fractional power will go away and we will have a polynomial of, अब देखते हैं कि कैसा polynomial आता है. So we will have dx की value as 4 times z cube dz. With this substitution, x की वैल्यू डाल देते z की पावर 4, so z की पावर 4 की पावर हाफ, z की पावर 4 की पावर 3/4, एंड dz की जगह, dx की जगह 4z क्यूब dz. So this becomes z square 4 outside into z cube dz, and नीचे आ रहा है 1 plus z cube. So as we can see, न्यूमरेटर में पावर ज़्यादा है from denominator. So what we will do is do the long division, right? न्यूमरेटर में हमारे पास क्या है? z की पावर 5 है, right? एंड डिनोमिनेटर में हमारे पास है z क्यूब प्लस 1. तो लॉन्ग डिविजन करते हैं. तो z5 z क्यूब प्लस 1, so probably I'll multiply with z square. So z5 plus z square, so negative negative, and minus z square. So z cube, no, so I cannot divide it any further, so this is the remainder, right? So this term now splits. तो न्यूमरेटर में जो डिविडेंड है उसको हम लिख सकते हैं डिवाइजर इनटू क्वोशिएंट प्लस रिमाइंडर. So z5 can be written as divisor, which is z cube plus 1, into quotient, which is z square, plus remainder, so minus z square. ठीक है, एंड डिनोमिनेटर में क्या है? z क्यूब प्लस 1. तो जब z क्यूब प्लस 1 से डिवाइड करेंगे, we will have 4 times z square and minus z square by z cube plus 1. Okay, so both of the integrals look very easy क्योंकि 4z square तो आराम से हो जाएगा. Then second वाले में this is also very easy. Z cube plus 1 का differentiation is 3z square. So what I will do is multiply and divide by 3 here. So z square dz, and what I will do is multiply and divide by 3. Okay, so इस term का differentiation ये है. तो this is, yeah, यहाँ पे you can do one more substitution, but I'll write the direct result 4 times z cube by 3 minus 4 by 3, and इसका इंटीग्रल आएगा log of z cube plus 1. But we have to still put back the value of z, and we have used x is equal to z की power 4. So हमें z cube की value डालनी पड़ेगी, I guess. So z, from this we can find z cube. So x की power 1 by 4 कितना है z, and so अच्छा, it's not visible, so probably visible now. So from this you can find z की x की power 3 by 4 is z cube, right? Okay, so 4 times x की power 3 by 4 by 3 minus 4 by 3 log mod x की power 3 by 4 plus 1 plus c. Okay, which is the same result as the backside of the book. So now let's move to our next problem. Okay, so right now looks like a difficult question, but let's see what we can do about this. So probably let's try taking out the highest power outside from the numerator. अगर ऊपर से x square कॉमन लेंगे तो x बाहर आएगा, नीचे 1 by x cube बन जाएगा, and 1 plus x square, 1 by x square का differentiation is like 1 by x cube. So let's try that. So numerator से अगर हम x square कॉमन लेने का ट्राई करें, so I'll get 1 by x square plus 1 and x4 dx. So now what will happen is x will go outside and square root के अंदर 1 by x square plus 1 divided by x की power 4 dx, and we have 1 by x cube, right? So I can write it as 1 by x square plus 1 into 1 by x cube, right, dx. So let's take 1 by x square plus 1 as some t. तो इसका differentiation x की power minus 2 का differentiation minus 2 divided by x cube, so into x की power minus 3, right? So plus 0, so into dx is dt. So I have 1 by x cube into dx, and which is equal to minus half dt. So with this substitution, our question becomes square root of t into minus half dt. So this is minus half outside, t की power half का integration, which is t की power 3 by 2 by 3 by 2. So which is minus 1 by 3 t की power 3 by 2 plus c. But what was t? So t was this, right? This here, this particular term. So our result becomes minus 1 by 3 into 1 by x square plus 1 की power 3 by 2 plus c. Okay, which is the result, yeah, at the back side of the book also. So let's move to our next problem. Okay, so you can do this question directly also. So this is 1 by 4 square minus 3x square dx. So you can use 1 by a square minus x square का integration square root के साथ, which is sin inverse x by a. So this will be sin inverse 3x by 4, but you will have to divide by 3, right? So आप directly कर सकते हो इसको 1 by 3 sin inverse 3x by 4 plus c. If you don't like this method, what you can do probably is make the coefficient of x square plus or minus 1. In this case, we can make it minus 1 by taking 9 common. So if I take 9 common, so what will go outside? So we will have 1 by 3 outside, right? Okay. And square root के अंदर आएगा 16 by 9 minus x square. And this is 1 by 3 outside. 1 by a square minus x square, direct formula, right? 4 by 3 minus x square. And answer is 1 by 3 into sin inverse x by a. So x divided by 4 by 3, that's it. So this is 1 by 3 sin inverse 3x by 4 plus c. Same result. So now let's move to our next problem. Okay, so we are given a quadratic in the denominator. So let's make the coefficient of t square या फिर जो भी x square है as plus or minus 1. So we can make it minus 1 in this case. So I'll take 2 outside, so root 2 will go outside, right? So 1 by root 2 outside, and inside I'll be left with square root के अंदर 3 by 2t minus t square. So हमने coefficient of t square क्या बना दिया plus or minus 1. So we'll look at the quadratic. So इसमें से negative common भी ले लेते हैं. So if I take negative common, this will become t square minus 3 by 2t. So we have to do completing of these squares for this. So t square minus twice of t into 3 by 4. So do completing of these squares, I have to add 3 by 4 square and subtract 3 by 4 square. So this is negative outside, and we have t minus 3 by 4 whole square. So minus 3 by 4 whole square. So negative multiply करने के बाद this is 3 by 4 whole square minus में t minus 3 by 4 whole square. Okay, so our integral changes and it becomes 1 by 3 by 4 square minus t minus 3 by 4 square. So this looks like the integral of 1 by a square minus x square, whose integral with square root. So this is sin inverse x by a. So let's use that and we will get half of sin inverse. So t minus 3 by 4 divided by 3 by 4 plus c. Okay, so let's simplify this. So 4 cancel कर देते हैं LCM लेने के बाद. So this result is हम बाहर क्या 1 by root 2. I'm sorry, 1 by root 2. So 1 by root 2 sin inverse 4t minus 3 divided by 3 plus c. Okay, so which is the result on the back side of the book also. So let's move to our next problem. Okay, so here we have a quadratic in the denominator which is not factorizable. Its discriminant is less than 0. So we can use numerator is equal to a times ddx of denominator में जो quadratic है plus b. So denominator, this is the value of numerator. So by this I want to split the numerator. But in this case we need not do that. We can just simply write 3x here and x square plus 9 here, क्योंकि x square plus 9 का differentiation will be 2x, which is available above, and the second one, so minus and 1 by root of x square plus 3 square, right? 9, which is 3 square, which can be done using a direct formula from the NCERT. So, but of course, but generally, अगर नीचे quadratic में linear term भी हो, you can always use this, and from this you can write numerator, which is 3x minus 1 should be written as a times radix of denominator, which is 2x plus b, and by comparison you can find कि भाई हाँ a का value आ रहा है 3/2 and b is -1. So and we will also find that basically क्योंकि हम यहाँ पे 3 बाहर लेंगे and 2 से divide करेंगे and we will get 2x, right? ठीक है, and x square plus 9 का differentiation क्या होता है 2x, so you can see 3/2 here also, right? And यहाँ पे you can see -1, right? ठीक है, and so let's use our formulas now and let's try to solve this. So this is 3/2 and यहाँ पे अगर हम substitution use करें, so which is x square plus 9 is equal to z, so 2x dx is dz, so 3/2 and 1 by root z dz. So 1 by root z का integration होता है 2 root z, so you can do z की power minus half का integration also, but this is 2 root z, and similarly यहाँ पे integral will be, so what is integration of 1 by x square plus a square with square root? So this is um, log mod x plus root of x square plus a square plus c. तो इसका रिजल्ट होगा माइनस लॉग मॉड x plus root of x square plus 3 square plus c. So यहाँ पे same thing, right? And our result finally is 3 times root z, but z कितना x square plus 9 and minus log mod x plus root of x square plus 3 square, which is 9, right? Okay. Plus c. Okay, so which is the result? Let's check. So yeah, this is the result on the back side of the book. So now let's move to our next problem. Okay, so in this problem we have to integrate square root of x square minus 2x plus 5. So let's look at this quadratic and do the computing of the squares for this. So I can do +1 and +4 अलग से, right? So this is x minus 1 whole square plus 4, which is 2 square, right? So this integral simply becomes x minus 1 ka square plus 2 square. So we'll use the formula integration of 1 x square plus a square inside the square root. So this is x by 2 square root of x square plus a square plus a square by 2 divided into log mod x plus root of x square plus a square plus c. So standard formula from NCERT. So this will be x minus 1 by 2 into square root के अंदर x square plus a square. So x minus 1 का square plus 2 square plus a square, which is 2 square divided by 2 into log mod x, which is x minus 1 plus में square root के अंदर x square plus a square, which is x minus 1 square plus a square plus c. Okay, so simplifying this, we already know this quadratic is basically uh, x square minus 2x plus 5, right? Yeah, for 5 minus 2x plus x square, right? This is x minus 1 into 2 into x square minus 2x plus 5 plus twice of log mod x minus 1 plus my square root of x square minus 2x plus 5 plus c. Okay, so very simple question, direct formula tha, and we can go to our next problem now. Okay, so in this problem probably we can lower the power of the question कि x की power 4 की जगह for example क्योंकि x square का differentiation 2x होता है and x is available in the numerator, so I'll just take the substitution x की power 2 as some t, so 2x dx is dt and x dx की जगह I can do a substitution as half of dt. So x dx की जगह आएगा half and dt, and नीचे जो x की पावर 4 है वो कितना बन जाएगा, x की पावर 4 will become t square minus 1. So now we can use a simple formula 1 by x square minus a square, right? So which is 1 by 2a log mod x minus a by x plus a. So standard formula from NCERT. So with this I will get 1 by 2 into 1 into log mod t minus 1 by t plus 1 plus c. So this is 1 by 4 log mod. So 1 by 4 log mod and t की जगह डालना है x square. So x square minus 1 by x square plus 1 plus c. Okay. Very simple question. So not too much to discuss here. So let's move to our next problem. Okay, so this is our next question. So here they have given a hint, but this is not a substitution for integration. This is a substitution just for the partial fraction. For example, method 1 for solving this question can be like x square divided by, so niche I can do 1 minus x square into 1 plus x square, right? Okay. And I can use partial fractions here. If I assume x square is equal to t, this term looks like t divided by 1 minus t upon 1 plus t, right? Okay. And you can split this as a by 1 minus t plus b by 1 plus t, right? So let's find the value of a and b. So after taking LCM, I get a times 1 plus t plus b times 1 minus t is equal to t. So by finding the coefficient or constant coefficient, we find constant coefficient से LHS पे 0 है, RHS में है a plus b, and coefficient of t भी check करते हैं. So this is 1 on the LHS, RHS में है this is a minus b. तो इन दोनों equations को solve कर लेंगे, add करेंगे तो 2a is 1, so a is half, and if a is half, b is minus half. So from all this I can split this integral. As क्योंकि a by 1 minus t, so a कितना है half divided by 1 minus t, but t क्या x square 1 minus x square dx, and then so let's just write the partial fraction just right abhi. So and plus b की value है minus half, right, divided by 1 plus t which is 1 plus x square. Okay, so both of these are solvable. So half outside, 1 by 1 minus x square dx minus half outside, 1 by 1 plus x square dx. So first goes like 1 by 2a into log mod a plus x by, so 2a is 1, so twice of 1 into log mod a plus x by a minus x, so 1 plus x divided by 1 minus x, and minus half tan inverse x plus c, and which is our result ki 1 by 4 log mod 1 plus x by 1 minus x minus half tan x tan inverse x plus c. But if you don't want to, you can solve the question normally you would. So not necessary you do this substitution. For example, let's try method 2 for this question. So our question is x square divided by 1 minus x4. So as I can see, denominator is factorizable. So this is 1 minus x square into 1 plus x square, and 1 minus x square is still factorizable. So this is x square 1 minus x 1 plus x into 1 plus x square, And now you can use partial fractions here क्योंकि numerator का power कम है, denominator में ज़्यादा power है. It is fourth power polynomial and numerator is quadratic. So you can directly use partial fractions to write x squared divided by 1 minus x into 1 plus x into 1 plus x square should be written as a by 1 minus x plus b by 1 plus x. एंड जो फैक्टराइजेबल टर्म नहीं है क्वाड्रेटिक में उसमें यू हैव टू राइट अ लीनियर टर्म अबव, तो सी एक्स प्लस डी डिवाइड बाय 1 प्लस एक्स स्क्वायर एंड यू विल हैव टू सॉल्व फॉर ए बी सी डी. ठीक है, तो ये थोड़ा बड़ा पड़ेगा मेथड, बट इफ यू डोंट गेट द डायरेक्ट सब्स्टिट्यूशन यू यूज द पार्शियल फ्रैक्शन नॉर्मली, राइट. तो a टाइम्स 1 प्लस एक्स इंटू 1 प्लस एक्स स्क्वायर प्लस b टाइम्स 1 माइनस एक्स into 1 plus x square plus cx plus d times 1 minus x into 1 plus x, which is so these two terms, which is 1 minus x square, right? Okay, so this is the LCM divided by all these terms, so these will cancel and this is equal to x square. So numerator को compare किया, and now let's compare the other coefficients. So just a second, I'll go back. Yeah. Okay. So by comparing coefficients, so एक टर्म और सिंप्लीफाई कर लेते हैं इसको. सो a टाइम्स 1 प्लस x देन x स्क्वायर प्लस x क्यूब, so and plus b, so 1 plus x square, so 1 and minus x plus x square minus x cube, and इनसे आ रहा है so I'll just open the fourth पूरा. तो इससे आ रहा है cx minus cx cube plus d minus dx square. Okay, so now let's compare the coefficient of constant coefficient. LHS में 0 है, RHS में क्या है, a plus b plus d. x का coefficient LHS में 0 है, RHS में है a minus b plus c. x स्क्वायर का coefficient LHS में है 1 and RHS में है a plus b minus d. Okay, and x cube का coefficient LHS में है 0, RHS में है a minus b minus c. Okay, so let's just solve the first and third. तो इन दोनों को अगर मैं subtract कर दूं तो a plus b cancel हो जाएगा and twice of d is minus 1, so d is minus half. And similarly अगर मैं सेकेंड एंड फोर्थ इक्वेशन को सब्ट्रैक्ट कर दूं तो a माइनस बी कैंसिल हो जाएगा and I will get twice of c is 0. So c is 0. So let's put these values in and a और b का वैल्यू भी कैलकुलेट करना अभी. So पहले वाली इक्वेशन में अगर d की वैल्यू अगर मैं माइनस हाफ डाल दूं I will get a plus b minus half is 0, so is equal to half. Okay, and second वाली इक्वेशन में मैं c की वैल्यू 0 डाल दूं तो a minus b is 0. So now we can solve these also to find twice of a is half. So if it is not visible I'll just go below. So now I can find twice of a, which is half, and a is 1 by 4, and if a is 1 by 4 b is minus 1 by 4. Okay, so very long question, but we were able to actually do the partial fraction, right? So if we put the values back into the partial fraction, so you can see a by 1. So I'll just copy this. Okay. So I'll just try to paste it here. Okay, so it's fine if it is visible. So, so a की value कितनी है? 1 by 4. So I'll just rub the values and put them here. So a की value है 1 by 4. B की value है -1 by 4. C की वैल्यू 0 है, D की वैल्यू -12 है. तो C की जगह क्या आएगा? 0 एंड D की जगह आएगा -12. ओके, एंड वी हैव आवर पार्शियल फ्रैक्शन. सो अब हमें इसका इंटीग्रल निकालना था, तो बेसिकली हमें इसका इंटीग्रल निकालना है. एंड वी हैव 3 इंटीग्रल्स. सो 1 by 4 outside, integration of 1 by 1 minus x dx, -1 by 4 outside, integration of 1 plus x dx. So and then -12 outside, 1 by 1 plus x square dx. So this is 1 by 4 log mod 1 minus x divided by -1, and this will be -1 by 4, and log mod 1 plus x divided by 1. So, and this one is tan inverse x by a, so tan inverse x by 1, right, plus c. Okay, and which is the same result as the previous time. So कहीं गड़बड़ हुई क्या? Okay, so हाँ यहाँ गड़बड़ हो गई. If a is 1 by 4, then b is also 1 by 4, right? Okay, क्योंकि a plus b is half, so if a is 1 by 4, the b is also 1 by 4. This is positive, positive, positive. Okay, so yeah. So let's write the final result just like the previous method की तरह. So this will become so negative, ठीक है, 1 by 4 अगर हम कॉमन ले लें, and log a minus log b, right? So this is negative, that is positive. So we'll get log of mod 1 plus x divided by 1 minus x. So same result, right? Okay. And okay, so by 1 minus x, right? So I have created this term using these two terms, right? And minus half tan inverse x plus c. Same result as the previous time. So now let's move to our next problem. Okay, so let's look at this quadratic and let's try to do completing of the square. So let's take negative common, and x square minus 2ax. So probably I can add a square and subtract an a square from this. So पहले तीन टर्म से क्या बन जाएगा? x minus a whole square minus a square. तो नेगेटिव मल्टीप्लाई करने के बाद this is a square minus x minus a का whole square. Okay, so this integral will become square root के अंदर a square minus x minus a का whole square, and we can use a direct formula. Integration of a square minus x square क्या होता है? So this is x by 2 a square minus x square plus में a square by 2 sin inverse x by a plus c. So from this our result becomes x minus a by 2 into square root के अंदर a square minus x minus a का whole square plus a square by 2 sin inverse x की जगह आएगा x minus a divided by a plus c. So the quadratic here can be simplified, right? It is the same as 2ax minus x square. So x minus a by 2 स्क्वायर रूट के अंदर 2ax माइनस एक्स स्क्वायर प्लस a स्क्वायर बाई 2 साइन इनवर्स x minus a by a plus c. So if it is not visible, I'll just drop it down. Okay. So now let's move to our next problem. Okay, so in this question, probably we can take sine inverse x as t, because we know sine inverse x ka differentiation is 1 by square root of 1 minus x square, so which is available. So let's try that. So let's take sine inverse x is equal to t. So 1 by 1 minus x square into dx is dt. So our integral will change and sin inverse x की जगह आएगा t and नीचे I have if we look carefully, so I'll write one more step here. Okay? So in between we have a step sin inverse x 1 minus x square and we have square root of 1 minus x square. Right? Okay. So we use उसका power क्या 3 by 2. Okay, so that's fine कि sin inverse x की जगह हमें t लिखना है and this 1 minus x square into dx is dt. But what about this 1 minus x square in the denominator? So 1 minus x square की value भी निकाल लेते हैं. So from this, which is our main equation, we can find x कितना है sin t and 1 minus x square कितना होगा 1 minus sin square t, because we have to write the answer in terms of t now, right? So 1 minus x square should be written as cos square t. Okay, so this will become cos square t. Okay, so I've written this term, right? Okay. This is cos square t. Sin inverse x क्या बन गया t and 1 square root के साथ वाला term is dt, right? So and this integral becomes t times secant square t dt. So how to solve this problem? तो इसको कैसे करें? So it doesn't look like a difficult question. We can use by parts, right? Okay, and by parts may if we remember the isolate, so we should take the difficult one in outside. So trigonometric algebraic. So let's take the algebraic term which is t outside and secant square t. Let's keep it inside. So t outside secant square t dt minus d dt of t secant square t dt and whole bracket dt. This is t into tan t minus 1 into tan t का integral dt. So which is so yeah. So now tan t का integral क्या होगा? So t tan t and tan t का integral is log mod secant x, right? Yep. So log mod secant x secant t, right, plus c. So probably you can take this negative also inside, so this will become t tan t plus log cos t, right? Okay. But in the original question हमारे पास t नहीं था, x था, so we still have to put the value of t here in terms of x. So let's calculate all that. So t की जगह क्या आएगा? Sin inverse x. So this will change. So t की जगह क्या आएगा? Sin inverse x. So what about tan t? तो अगर आपके पास sin t अवेलेबल है and you already know from this cos t कितना है? Square root of 1 minus x square, right? And you also have tan t then, right? ठीक है, tan t कितना है? X divided by square root of 1 minus x square. So this is x in divided by 1 minus x square, right? Okay. Plus log mod cos t. So cos t is 1 minus x square with square root. Okay. And probably if you want to, you can take this square root outside and half लिख सकते हो बाहर, and you can leave as it is also. So I'll leave it as it is. So let's move to next problem now. Okay, so this here is the ठीक है थोड़ा difficult question है. So rather than treating it as an integral, treat it as a question from trigonometry. So forget about the integral right now. So let's look at this cos 5x cos 4x divided by 1 minus 2 cos 3x. The first thing is we have to simplify this using trigonometry, and simplified जो भी term आएगा उसको integrate करेंगे. So let's use our formulas now. So if your memory is good, you will remember from class 11 cos A plus cos B is nothing but twice of cos of A plus B by 2 into cos of A minus B by 2. So you can prove it very easily. So from this formula, our numerator becomes twice of cos of 9x by 2 into cos of x by 2. And let's use half angle formula in the denominator also. So I'll use formula in the denominator. क्या use करें? Cos 3x. So cos 2 theta, right? 2 theta. I will write as 2 cos square theta minus 1, right? Okay. So I'll do denominator में जो एक cos 3 theta है उसको मैं लिखूंगा twice of cos square x by 2 3x by 2 minus 1. Okay, so this is twice of cos 9x by 2 into cos x by 2. So and 1 minus 4 cos square 3x by 2 plus 2. So मैंने ये क्यों यूज किया? Because 3x by 2 is in the same form, right? मैंने half angle formula क्यों यूज किया? Is in the same form as x by 2 और 9x by 2. So we'll find some more relations here. So इसको और simplify करते हैं. So what we have is 2 cos 9x by 2 cos x by 2 and नीचे आ रहा है 3 minus 4 cos square 3x by 2. Okay, so looking at these 3 and 4, I am remembering a formula कि भाई cos 3x 3 theta from class 11th. You can remember if it is 4 cos cube theta minus 3 cos theta. So denominator में कुछ ऐसा बन रहा है. So to make that formula, what I will do is multiply with cos theta, right? So multiply with cos 3x by 2 in the numerator and denominator. Okay, so इसके लिए what I will do is multiply with cos 3x by 2 in the numerator and denominator, and this will become twice of. ठीक है, ऊपर बहुत सारे टर्म्स आ रहे हैं cos x by 2 cos 3x by 2 cos 9x by 2, बट डिनोमिनेटर में अगर मैं नेगेटिव कॉमन ले लूँ, आई एम लेफ्ट विद 4 cos cube 3x by 2 minus 3 cos 3x by 2, which using our formula becomes cos 9x by 2. So this is minus 2 cos x by 2 cos 3x by 2 cos 9x by 2 divided by minus cos, तो माइनस तो ठीक है माइनस मैंने ऊपर लिखा हुआ cos 9x by 2. So this and this will cancel. Okay, so now last formula left, for this question. So let's insert some space here. So our result which is, अब इसको इंटीग्रेट करना है, राइट? सो प्रोडक्ट में तो नहीं छोड़ेंगे इसे. So what we can probably use is twice of cos A cos B, and this is cos of A plus B plus में cos of A minus B. If you remember, cos of A plus B is cos A cos B minus sin A sin B, and this is cos A cos B plus sin A sin B. If you add them, sin A sin B will cancel and you'll get twice of cos A cos B. So अगर मैं इस 2 को भी absorb कर लूँ, and twice of cos A cos B is cos of A plus B, which is x by 2 plus 3x by 2, which is 2x, and plus में cos of A minus B, x by 2 minus 3x by 2 is minus x. So this is minus cos 2x, and ये नेगेटिव बाहर से आया, अंदर वाला ऐसे cos of minus x is cos x, right? ठीक है, so this is cos x, नेगेटिव बाहर से आया, ठीक है. So this is what all these terms simplify to, right? Minus cos x minus cos 2x, ठीक है. So this question simplifies to integral of minus cos x minus cos 2x. So minus outside cos x का integration and minus outside cos 2x का integration. So cos x का integration is sin x, and cos 2x का integration will be sin 2x by 2 plus c. So if it is not visible, I'll just go down. Okay. So very simple result. So पूरे क्वेश्चन में ट्रिग्नोमेट्री के फॉर्मूलाज थे rather than integration, ठीक है. So that's why it's an important question. So I'll repeat what we have done here quickly. So हमने cos A plus cos B यूज किया to form the product, and नीचे हमने 3x को भी 3x by 2 वाले फॉर्म में लिख दिया using half angle formula. And then we notice नीचे 3 and 4, and जिससे हमने इन्फर किया कि हम cos थीटा मल्टीप्लाई डिवाइड कर देते, so that it becomes cos 3 थीटा का फॉर्मूला, and suddenly cos 9x by 2 कैंसिल हो गया, ठीक है. and then हमने twice of cos A cos B का फॉर्मूला यूज किया, cos of A plus B plus में cos of A minus B. Okay, so let's move to our next problem now. So again we have a very good question here, so I'll mark it also important. So here we have to use certain properties. For example, numerator में we will use x cube plus y cube, and we will use the property from class 9th that this can be factorized as x plus y into x square minus xy plus y square. So using this property I can write numerator as, so ये किसका क्यूब है? So पहले तो उतना ही लिख लेते हैं. So this is sin square x का क्यूब, right? ठीक है, प्लस cos square x का क्यूब. So using our formula x plus y कितना बनेगा? sin square x plus cos square x. And second bracket में we will get sin की power, so sin square x का square, so this is sin 4x minus sin square x into cos square x plus में cos 4x divided by sin square x cos square x. So this term becomes 1, right? Okay, because sin square x plus cos square x is 1. So let's think further. इसमें क्या करें? So probably I will try to form a perfect square again to decrease the power further. So I guess we can do the question in more than 2 ways now. So let's say एक मेथड ऐसा बना लेते हैं कि ऊपर और नीचे का पावर सेम है, सो प्रॉब्ली इट शुडंट बी अ प्रॉब्लम. सो अगर मैं डिवाइड कर दूं डिनोमिनेटर को सारे टर्म से अलग अलग, तो साइन 4x बाय साइन स्क्वायर एक्स कॉस स्क्वायर एक्स क्या बन जाएगा? तो दिस विल बिकम साइन, तो साइन 4x बाय साइन स्क्वायर एक्स कॉस स्क्वायर एक्स. तो यहाँ पे एक साइन का टर्म कैंसिल हो गया, ऊपर बचेगा साइन स्क्वायर एक्स एंड दिस विल बिकम tan स्क्वायर एक्स, राइट? ठीक है, which can be very very easily integrated. And similarly second term will be -1, right? Again plus cos 4x divided by sin square x cos square x. So you can cancel this term with this term. So in the next step, so in the next step this will become, so पहला इंटीग्रल किसका आ रहा है? tan square x, right? Then simply dx का इंटीग्रेशन नेगेटिव साइन के साथ, then simply cot square x का इंटीग्रेशन. तो पहले वाला इंटीग्रेशन को कर सकते हैं secant square x -1, राइट? ठीक है, this is x and this can be done also using cosec square x -1. So tan x minus x cosec square x का इंटीग्रेशन is minus cot x minus x plus c. So this is tan x minus cot x minus 3x plus c. So let's try another method maybe. So on the right side. So any other way to proceed for this? Okay, so what maybe I can do is sin 4x को मैं लिख सकता हूँ sin square x का स्क्वायर, ठीक है. cos 4x को मैं लिख सकता हूँ cos square x का स्क्वायर. And what I can do is add 2 sin square x cos square x. एंड बट मेरे पास न्यूमरेटर में तो माइनस है, सो ये कितना बन जाएगा? -3 sin square x cos square x. So if you add both of these, this is minus sin square x cos square x, like the previous term. ठीक है, so why I have done this? Because the first three terms will become perfect square again, just like previous time जैसे sin square x plus cos square x cancel हुआ था. अभी I am getting sin square x plus cos square x whole square. ठीक है, so this is also 1, right? ठीक है, but -3 sin square x cos square x. So पहला इंटीग्रल बनेगा 1 by sin square x plus cos square x into cos square x dx and -3 and dx, right? ठीक है, तो पहला वाला इंटीग्रल करने के लिए देयर इज अ ट्रिक इन्वॉल्व. सेकंड वाला तो हो चुका है. पहले वाले में यू हैव टू राइट द न्यूमरेटर में जो 1 आया sin square x plus cos square x. So it will be clear in a second. क्यों? So once we divide, so we will get 1 by cos square x plus 1 by sin square x dx. So now we can see it's a very very simple integral. किस चीज का इंटीग्रल है? secant square x का, right? This is cosec square x. And which is tan x minus cot x minus 3x plus 3. So जस्ट लाइक द प्रीवियस टाइम वी गेट द सेम आंसर, बट यहाँ पे ये स्टेप इंपॉर्टेंट है, यहाँ पे लोग गड़बड़ कर देते, ठीक है, इफ यू आर यूजिंग दिस वन। तो और अदरवाइज है ना, पहले टर्म को कैंसिल करने के बाद यू कैन जस्ट डिवाइड इट हियर, जब फोर्थ पावर बाय फोर्थ पावर हो गया था, then you can just divide it and write the separate terms also. Okay, so let's move to next problem. Okay, so in this question, ऊपर we have x की power half and x की power 3/2 का differentiation is x की power half type of term, right? Okay, so 3/2 x की power half, right? So basically it is similar to root x, right? So I'll take x की power 3/2 is equal to t. So 3/2 times x की power half dx is dt. So root x dx is 2/3 dt. And x की power 3/2 मेरे पास डिनोमिनेटर में अवेलेबल है, x क्यूब है, राइट? तो इससे मुझे पता है x क्यूब की वैल्यू कितनी है. So x cube is t square, right? So let's do all these substitution and change the integral, and our integral will become 2/3 dt. And denominator में we will get a cube minus t square. Okay, so let's take 2/3 outside and a cube जो डिनोमिनेटर में उसको मैं लिख सकता हूँ किस चीज का स्क्वायर है, 3/a की पावर 3/2 का स्क्वायर है, ठीक है, माइनस टी स्क्वायर. तो a की पावर 3/2 को मे बी यू कैन राइट b, दिस इज b स्क्वायर माइनस t स्क्वायर, राइट? एंड व्हाट इज इंटीग्रेशन ऑफ 1/√of a स्क्वायर माइनस x स्क्वायर dx? तो दिस इज sin inverse x by, so this integral will be 2/3 sin inverse t divided by the constant term which is a की power 3/2 plus c. But what is t? So t is x की power 3/2, right? So this is 2/3 sin inverse x की power 3/2 divided by a की power 3/2 plus c. So maybe you can write the square root of the whole term in the inside, right? Half हटा देते हैं numerator and denominator से, and we can write 2/3 sin inverse square root of x cube by a cube, right? Same as the book. So let's move to next problem. Okay, so again we have a very good problem. I'll mark this one also important. So important problem. So again this is a question from trigonometry rather than integration. So let's just simplify this term. So cos x minus cos 2x divided by 1 minus cos x. So numerator में let's use cos a minus cos b. So what can we use for cos a minus cos b? So we can use twice of, so minus 2 times sine of a plus b by 2 into sine of a minus b by 2. So our numerator will become minus 2 sine of x plus 2x is 3x by 2 into sine of a minus b by 2. X minus 2x is minus x by 2. Okay. In the denominator अब देखो x by 2 आ रहा है, so let's use 1 minus cos x को भी x by 2 के फॉर्म में कन्वर्ट कर देते हैं. So this is twice of sine square x by 2, right? So this is for denominator, this is for numerator, and this will become twice of sine square x by 2. So 2 cancels and यहाँ से नेगेटिव बाहर आएगा न्यूमरेटर में से, तो नेगेटिव नेगेटिव पॉजिटिव sin 3x by 2 into sin x by 2 डिवाइडेड बाय sin x by 2. तो यहाँ तक तो ठीक है, ये दोनों कैंसिल हो गए, ठीक है, नीचे एक साइन स्क्वायर बच रहा है, आई एम सॉरी। तो यहाँ तक तो ठीक है कि नीचे एक साइन स्क्वायर बच रहा है। So what can we do about this? Sine 3x by 2 divided by sine x by 2. So numerator में we can use sine 3 theta का formula, which is 3 sine theta minus 4 sine cube theta. So triple, ठीक है. So and we can write the numerator in terms of x by 2 and we can cancel sine x by 2. So let's do that. So just a second. Yeah. So this will become 3 sine x by 2 minus 4 sine cube x by 2 divided by sine x by 2, and this will simplify to 3 minus 4 sine square x by 2. Okay, so this is the term we can probably solve very easily. So let's write this in the integral. Okay? So our this term simplifies to, so as written below, 3 minus 4 sine square x by 2. So we have two integrals now. So एक है 3 outside dx का integration minus 4 outside sine square x by 2 का integration. So how can we integrate sine square x by 2? So if you remember from your NCERT, even power hai, so you can use half double angle formula. So this is 3x minus 4 and you can use double angle formula as 1 minus cos x by 2, right? So 3x, first integral is minus 2 times dx, second integral is plus 4 times cos x dx. So this is okay. So this simplifies to 3x minus 2x plus 4 sin x plus c, and this is x plus 4 sin x plus c. So 4, अच्छा ये वाला 4 और ये 2 cancel हो गया, this is also 2, so this is 2 and this is 2. Okay, otherwise this is the answer given on the back side of the exemplar also. So we will move to our next problem. तो काफी simple तो नहीं बोलूँगा, but you have to remember your formulas from trigonometry, right? ठीक है. So okay, so if you remember our substitutions, I already said a square minus x square के case में we do x is equal to a sin theta. And so if you have term like this, then this is a good substitution. And for term like x square plus a square, similarly you can do x is equal to a tan theta. And a x square minus a square के case में you can do x is equal to a secant theta. So here this term is x की power 4. So यहाँ पे x, आप x की जगह तो ये देखो, अगर यहाँ पे x square minus 1 होता, good substitution was x is equal to secant theta, right? But यहाँ पे x की power 4 है, तो we'll put x square is equal to secant theta as given as a hint given by NCERT, and this is also implied from here also, right? कि अगर मैं x की power 2 को secant डाल दूँ, तो this will become secant square theta minus 1, which is tan square theta, and we can simplify it further. So let's do that. So let's put x square is equal to secant theta. So differentiating this, I will get 2x dx is secant theta tan theta d theta. So our integral will change and our new integral will be तो x की जगह क्या लिखेंगे, जो ये डिनोमिनेटर में हमारे पास x, सो हमारे पास 2x dx तो नहीं है, बट what I can maybe with for before transforming, let's create x square here, right? ठीक है, and this is x की power 4 minus 1 and ऊपर आ जाएगा x dx, right? ठीक है, क्योंकि I have multiplied and divided by x, and you can what you can do is multiply and divide by 2 also, right? तो मैंने इसको इस फॉर्म में तो लाया कि मैं अब मैं सब्स्टिट्यूशन कर सकता हूँ. लेट्स डू इट नाउ. so half times, so um, half times 2x dx की जगह आएगा secant theta tan theta d theta. so this is this numerator, right? ठीक है, and x square की जगह आएगा secant theta, and x की पावर 4 की जगह क्या आएगा, secant square theta minus 1. so this is half secant theta tan theta. अच्छा, दोनों तो कैंसिल हो गए, and secant square theta minus 1 is tan theta. so this is root of tan square theta, which is tan theta. so these two also cancel, and we have integral as half of d theta, and this is half theta plus c. But what was theta? So we can use our original equation to find कि theta is secant inverse x square. So our answer is half of secant inverse x square plus c. Okay, so let's move to our next problem. So we have to do this question as the limit of sums. Okay, so formula goes like this: a to b definite integral fx dx can be done using limit n tending to infinity and b minus a by n into summation. तो यहाँ पे सब सारे टर्म्स आएंगे, f of a plus f of a plus h till f of a plus n minus 1 into h. So here n and h have a relation. We have n is approaching infinity, h is approaching 0, and we have n या फिर h की वैल्यू होती है b minus a by n. So they have a relation. So we are adding up all the strips to find the area. So let's use this formula, and so our this integral will become limit n tending to infinity. So b minus a is 2 minus 0 here, so this is 2 by n. F of a, so this is our fx is x square plus 2, right? X square plus 3. So f of a कितना होगा? So our a is 0, so f of 0 plus f of 0 plus h, right? ठीक है, plus f of 0 plus 2h till f of 0 plus n minus 1 into h. So this is limit n tending to infinity, 2 by n. F of 0, so this is 0 square plus 3. F of h will be h square plus 3. F of 2h will be 2h ka square plus 3, and so on, so on, so on. F of n minus 1 h will be n minus 1 into h ka whole square plus 3. Okay, so we are getting limit n tending to infinity, 2 by n, and we have 0 square. ठीक है, अगर h square common ले लें, so if I take h square common, so I'm left with 0 square plus 1 square plus 2 square till n minus 1 का square plus 3 plus 3 plus 3. So if we see carefully, if we drop this 0 square, right? Okay, we have n minus 1 terms in this and n terms in this, right? So I will just mark that. So these are n minus 1 terms, and these are n terms. तो ब्रैकेट क्लोज नहीं किया था, ठीक है. So now we will use special series. We will use summation r square, r going from 1 to n. So this is n into n plus 1 into 2n plus 1 by 6. So this is 1 square plus 2 square plus 3 square till n square. So but यहाँ पे हमें n की वैल्यू डालनी है n minus 1. So this is limit n tending to infinity 2 by n. And h की वैल्यू भी डाल देते हैं. H we already know for this question is 2 by n, right? Okay, so this is 2 square by n square, right? Okay. And this is n minus 1 into n plus 1, which is n into 2n plus 1 में जब n minus 1 डालेंगे, so n minus 1, so this will become 2n minus 1 divided by 6. So I'll use this bracket outside, and plus 3n. Okay, so let's divide, so let's multiply this 2 by n inside. So I'll be left with limit n tending to infinity 8 by n cube, and यहाँ पे है n minus 1 into n into 2n minus 1 by 6. So this is cubic by cubic, so we'll divide by highest power, which is n cube in the numerator and denominator, and second वाले term में if I multiply 2 by n, तो n cancel, right? So this is 6 times n by n, so these two cancel, right? Okay. So okay, so this is limit n tending to infinity. So अब मैं यहाँ पे n क्यूब को n into n लिख के इन तीनों टर्म से डिवाइड कर रहा हूँ. So this is 8 by 6, which is 4 by 3. अगर मैं n minus 1 को n से डिवाइड करूँ, this is 1 by 1 minus n. So 1 minus 1 by n. So and this is 1, and this is 2 minus 1 by n. Okay, and plus 6. And now I can let go of n to be infinity, and some terms will become 0. So limit apply करने पे आ रहा है 4 by 3 into 1 minus 0 into 1 into 2 minus 0 plus 6. So this is 8 by 3 plus 6, which is equal to 8 plus 18 by 3, and this is 26 by 3. So let's check the answer. So you can of course calculate the integral and check कि ये 26 by 3 आ रहा है कि नहीं. So of course, so 26 by 3, which is correct. And to do, while doing this question, of course you can do a single step to do x cube by 3 plus 3x, and limits are 0 to 2, right? So that will give you 8 by 3 plus 6 minus 0 plus 0, so which is again 26 by 3, right? Okay, same result. Okay, so now let's go to next problem. So again we have to do the question using limit of sum, so we can do it directly to check पहले से ही आंसर क्या आएगा. So e की power x 0 to 2, right? This is e square minus e की power 0, which is e square minus 1. So let's do it using limit of sum. So formula goes like this: a to b fx dx can be calculated using limit n tending to infinity, and if you want to, you can write b minus a outside also, right, by n. And then we have summation f of a plus f of a plus h, f of a plus 2h, and so on, so on, so on, till f of a plus n minus 1 into h. And here we have a relation between n and h ki bhai n is tending to infinity, h is tending to 0, and h is nothing but equal to, so h is nothing but b minus a by n, right? Okay. So this is the width. So these are the relations. So from this question, we can write it as a summation, which will be limit n tending to infinity. So 2 minus 0 by n, so 2 by n, f of a, so our fx is e to the power x, and a is 0, and b is 2. So f of a, f of 0, right? Okay, f of 0 is e to the power 0. So okay, I'll write f of 0 plus f of h, 0 plus h, f of 0 plus 2h, so 2h, until f of n minus 1 into h. So this is limit n tending to infinity, 2 by n. F of 0 is e to the power 0, which is 1. Then e to the power h plus e to the power 2h plus e to the power 3h, and so on, so on, so on, till e to the power n minus 1 into h. So if we look carefully, this time we don't have a special series, but we have a GP, which is also very simple to calculate. And how many terms are there? There are n number of terms here. N की values, okay? So we have n number of terms. So n terms, a is 1, and common ratio कितने? E की power h. So if we remember, a sum of n terms for a GP is a times r to the power n minus 1 divided by r minus 1. So let's use this. So this is limit n tending to infinity, 2 by n, and this is a, which is 1, into e की power nh. So e की power h की power n, right? ठीक है, minus 1 divided by e की power h minus 1. So let's look into this term. So what is this term? So limit n tending to infinity, we already have the relation between n and h. We already know h is nothing but 2 by n, so which implies n into h is 2. So I'll use that in the numerator, because I have e की power nh, right? Minus 1 divided by e की power h minus 1. So nh is 2. So this will become limit n tending to infinity, 2 by n, and this is e square minus 1 divided by e की power h minus 1. So let's take twice of e square minus 1 outside. So twice of e square minus 1 outside the limit, and let's change the limit n tending to infinity की जगह limit h tending to 0, and जो ये 1 by n है उसकी जगह हम क्या लिख सकते हैं? 2 by h, right? ठीक है, so this 1 by n can be written as h by 2, I'm sorry. So this can be written as h by 2, and this 2 and this 2 will cancel, and नीचे क्या, e की power h minus 1. So I have changed the limit because this is a standard formula from NCERT कि limit x approaching 0 e की power x minus 1 by x कितना होता है? 1. So we can solve this question also now. This is e square minus 1 limit h tending to 0 and h by e की power h minus 1. So this limit we know is 1. So answer is e square minus 1. ठीक है, तो ये तो हमने पहले भी चेक कर लिया था कि यही आएगा. So let's move to next problem now. Okay, so e की power x का differentiation e की power x होता है, but e की power x is not available in the numerator. So let's just create that term. So 0 to 1. So नीचे जो e की power minus x है हम उसको उल्टा कर देते हैं. And this term integral simplifies to e की power x divided by e की power 2x plus 1. So now we can of course take e की power x is equal to z. So e की power x into dx will be dz. So ऊपर वाले दोनों term will become dz, and we can change the limits also when x is 0. Z कितना? E की power 0. Z is 1. And when x is 1, z is e की power 1, so z is e. Okay. So these are the two new values. So this integral changes to from 1 to e, and e की power x into dx is dz, and e की power 2x कितना हो जाएगा? Z square, right? This is z square plus 1. So this is tan inverse z, and limits are 1 to e, and our result is tan inverse e minus tan inverse 1. So tan inverse e तो मुझे नहीं पता, but tan inverse 1 is pi by 4, right? So which is the same result as NCERT. So let's move to next problem. Okay, so not that tough, but a tricky question. So uh, we can convert the whole integral maybe in terms of sin x and cos x. So 0 to pi by 2, I can write tan x as sin x by cos x divided by 1 plus m square sin square x by cos square x. So this becomes cos square x plus m square sin square x, and जब cos square x ऊपर multiply होगा, this will become sin x into cos x. So which is good because sin x into cos x, ठीक है, sin square x का differentiation. So sin square x का differentiation is twice of sin x into cos x. So which is available, and similarly cos square x का भी differentiation यही होता है, बस minus sign आता है, minus 2 sin x cos x आता है. So if you want to, you can take the whole denominator as z. So let's do that. So या फिर आप पूरे डिनोमिनेटर को sin square x के टर्म में भी ला सकते हो, cos square x को 1 minus sin square x डाल के, but up to you. I'll just do so I'll write it here also. Cos square x का differentiation क्या होता है? 2 sin x cos x. So I'll just work with this. So I'll just say denominator को मैं z डाल देता हूँ, ठीक है? So cos square x plus m square sin square x is z. ऐसा कुछ कर सकते हैं? So let's try. So minus 2 sin x cos x, ठीक है? Cos x sin x. So ठीक है, sin x into cos x plus m square into 2 sin x cos x into dx is dz. Okay, so that's a good start. I can take sin x cos x dx here. I can keep it here, and बच क्या रहा है? तो अगर ये मैं बाहर निकाल रहा हूँ sin x into cos x, तो minus 2 plus 2m square बच रहा है अंदर. So let's take all of these terms to the right side. So sin x cos x dx is, let's take let's divide by this terms, and 2 बाहर भी ले लेते हैं, and m square minus 1 dz. Okay, I will use this as the substitution, and if you want to, you can change the value of limits also. So I'll change them also. So when x is 0, तो z की वैल्यू कितनी आ रही है? तो z is cos square 0 plus m square sin square 0. So this term is 0, and so z is 1. ठीक है? So then let's just, okay, so when x is pi by 2, z is cos square pi by 2 plus m square sine square pi by 2. So this term goes to 0 and this is 1. So this is z square, z is m square. Okay, so my new integral will be 1 to m square. So 1 to m square and sin x cos x dx की जगह आएगा 1 by 2 and m square minus 1 बाहर लिख देते because this is just a constant and dz and यहाँ पे आएगा 1 by z, right? ठीक है, so simple. So this is 1 by 2 m square minus 1 and log mod z and limits are 1 to m square. So 1 by 2 m square minus 1 log m square minus log 1. So log 1 is 0 and m square में से probably you can take 2 outside and cancel it. So 2 by 2 m square minus 1 log mod m. Okay, so which says our result is 1 by m square minus 1 into log mod m. So which is the result given in the exemplar also. So let's move to our next problem. Okay, so in this problem we are given a quadratic in the denominator but in square root. तो फैक्टराइज फॉर्म नहीं चाहिए होता हमें, कंप्लीटिंग ऑफ द स्क्वायर करके हमें जो फॉर्म मिलता है वो चाहिए होता है. सो लेट्स राइट द क्वाड्रेटिक सेपरेटली टू सेव सम स्टेप्स. So x minus 1 into 2 minus x. So this is 2x minus x square minus 2 plus x. So this is minus x square plus 3x minus 2. So let's take negative outside. This is x square minus 3x plus 2. Okay, so completing of the square start karte. So x square minus twice of kya hai? X into 3 by 2. So let's add 3 by 2 square and subtract 3 by 2 square plus 2. So these three terms will become a perfect square. So this is x minus 3 by 2 whole square and minus 9 by 4 plus 2 and which is minus 1 by 4. So x minus 3 by 2 whole square minus 1 by 4, yeah, so which is minus half square. So negative अंदर multiply कर देंगे, this is half square minus x minus 3 by 2 whole square. Okay, so in this integral is very easy now. तो यहाँ पे जो एक quadratic है उसको मैं क्या लिखूंगा, half completing of the squares के बाद half minus x minus 3 by 2 whole square and we can use the integral 1 by square root of a square minus x square which is sin inverse x by a. So using this formula we have sin inverse x minus 3 by 2 divided by half and the limits are 1 to 2. So sin inverse 2x minus 3, so by 2 and by 2 वो cancel हो गए, 1 to 2. So this is sin inverse 2 डालने पे वैल्यू कितनी आ रही, 4 minus 3 minus sin inverse 1 डालने पे आ रही minus 1. So 1 डालने पे आ रहा 2 minus 3. So sin inverse 1 minus sin inverse minus 1. So sin inverse 1 is pi by 2, sin inverse minus 1 is minus pi by 2 and this is pi by 2 plus pi by 2 which is pi. Same result as the exemplar. So let's move to our next problem. Okay, so not a very difficult problem. Okay, let's just take 1 plus x square is equal to some t. So 2x dx is dt and we can find the value of x dx as half of dt. Let's change the limits also right now only. So when x is 0, t is 1 plus 0 square, so t is 1. And when x is 1, t is 1 plus 1 square, so t is 2. So our limits goes from 1 to 2, and x dx की जगह आएगा half dt, and 1 plus x square is t, so this is root t, right? So we have to integrate t की power minus half, right? So whose integral is, so 1 by root t का integral होता है 2 root t, right? So you can do it t की power half divided by half also, okay? So and our answer, so let's just rub this. So our answer becomes so half half cancel हो गया, right? So this is root t going from 1 to 2. So this is root 2 minus root 1. Answer is root 2 minus 1. Okay. Same as the exemplar. So let's move to our next problem. So again we have a good question, not a very difficult one, but you have seen these questions in the definite integration in NCERT also. So 0 to pi x sin x cos square x dx. इसको I will call as my original integral I, and then I will use the property कि 0 to a, so 0 to a fx dx is same as 0 to a f of a minus x into dx. Queen's rule. So whatever you call this, but from NCERT property 3 4 I don't know, but so this integral will become 0 to pi, and this is we are doing to eliminate this x, right? ये जो x है बाहर इसको eliminate करने के लिए कर रहे हैं. So then we get pi minus x sine of pi minus x into cos square pi minus x. So sine of pi minus x is sin x, and cos of pi minus x is minus cos x, but उसका हमें square करना. So I is 0 to pi minus x sin x into cos square x dx. So what we will do now to eliminate that x, we will add the original equation 1 and the second equation 2 to find twice of I, and we will eliminate x. So we will find 1 plus 2 से twice of I is 0 to pi, and we will be left with just pi here, right? Into sin x into cos square x dx. So I is pi by 2 times 0 to pi sin x into cos square x dx. So now we can do a simple substitution. We can put cos x is equal to z. So sin x dx with negative sign will be dz. So sin x into dx will be minus dz. Okay, so our integral will become pi by 2, and sin x into dx is minus dz. So let's put negative outside. तो बाहर आ गया minus pi by 2, and cos square x की जगह क्या आ जाएगा z square. Okay, and let's change the limits also. Probably we can change the limits also. So when x is 0, z is cos 0, z is 1, and when x is pi, z is cos pi, so z is -1. So our limits are now going from 1 to -1. So 1 to -1. So let's absorb this negative here and change the flip the sign. So pi by 2 and यहाँ पे हम limits change कर देते हैं, -1 to 1 कर देते हैं, right? Z square dz. So okay. So we find integral is pi by 2 times z cube by 3 -1 to 1. So pi by 6. So 1 cube minus में -1 का cube, right? So this is pi by 6 into 2, which is pi by 3. Same result as exemplar. So let's move to our next problem. So this question is directly from the substitutions, as I was saying कि a square minus x square के case में you should do a substitution, x is equal to a sin theta, and this is what the hint is also saying, right? यहाँ पे square root के अंदर क्या है, 1 minus x square. So forget about 1 plus x square, which is without the square root. Focus on this one, and we should put x is equal to sin theta in this. So okay, let's do that. X is equal to sin theta डालते हैं. So dx will be cos theta d theta, and limits will also change. So when x is 0, so we already know from this theta is sine inverse x. So theta is sine inverse 0. So theta is 0. And when x is half, theta is sine inverse half. Sine inverse half is pi by 6. Okay, so using this, we have our new integral, which is going from 0 to pi by 6. dx की जगह आएगा cos theta d theta. And 1 plus x square की जगह आएगा 1 plus sin square theta. And this is square root के अंदर 1 minus sin square theta. So 1 minus sin square theta is cos square theta, and this will become cos theta, and numerator में वो term cancel हो जाएगा. So we have 0 to pi by 6 cos theta d theta, 1 plus sin square theta into cos theta. So this term, right, cos theta. So these two will cancel. So now the question remains how to solve this question. ठीक है कि 1 by 1 plus sin square theta. तो इसके लिए क्या substitution करें या फिर क्या तरीका यूज करें? So what you can do is so this is a standard question जहाँ पे if you have terms like 1 by a cos square theta plus b sin square theta plus c and sin theta cos theta. Okay, so if you, and let's say plus d also. So but it doesn't matter. If you have terms like these, you can divide by cos square theta in numerator and denominator, and convert the denominator into a quadratic in terms of tan, and ऊपर secant square theta can be used for substitution. ठीक है? So I'll do the same thing here to do this problem. Okay, so I will divide by cos square theta in the numerator and denominator. तो ऊपर आ जाएगा secant square theta, and नीचे आ जाएगा secant square theta plus tan square theta divide by cos square theta in numerator and denominator. And denominator में जो आपका secant square theta है, I will write in terms of tan theta. So this is 0 to pi by 6. So 0 to pi by 6 secant square theta, and this will become 1 plus tan square theta. So this will become 2 tan square theta plus 1. So let's use tan theta is equal to z. So secant square theta d theta will be dz. So when theta is 0, तो z कितना है? Z is tan 0. So z is 0. And when theta is pi by 6, z is tan pi by 6, which is 1 by root 3. So our new integral will become 0 to 1 by root 3 dz and 2z square plus 1, twice of z square plus 1. So let's take 2 outside. We will be left with z plus half. So half ko we can write as 1 by root 2 square. So this is the integral of 1 by x square plus a square, which is 1 by a tan inverse x by a. So this is 1 by a, 1 by root 2 into tan inverse x, which is z by 1 by root 2. Limits are 0 to 1 by root 3. So this is 1 by root 2 tan inverse root 2 into z. Limits are 0 to 1 by root 3. Okay, so let's put in the limits. So this is 1 by root 2 tan inverse root 2 into 1 by root 3. This is the first term, and minus tan inverse root 2 into 0. So this is 1 by root 2 into tan inverse root of 2 by 3. Okay, minus tan inverse 0, which is 0. So same as the exemplar. So okay, so thank you for watching. In this we have done 34 questions, which were the short questions from the exemplar. So make sure to like, share and subscribe. So notes will be available below the video only as a Google Drive link. Thank you.